Hello, my fellow hopeful malcontents. I have another report here from the front lines of hell. Uh, Currently, Ohio, and I'm sure other states, are going through a gerrymandering battle. We passed two amendments to try to prevent this, but, alas, it didn't work. But like I said, I'm here with solutions. This is a mathematical way to prevent gerrymandering. There's actually two methods here. The first one, we're going to say this is your area that needs to be split up, or state, or whatever. They're all evenly cut out pieces. Each of these has a value of 1, each has a perimeter of 4. You add up the perimeter of each of those 6 districts, you get 24. Then I made several other examples so we could look at the effect gerrymandering would have. We got this big C-shaped one, kind of, reminiscent of Ohio in a Jim Jordan's duck-shaped district. All of these, I did the math for you, added up the perimeters, 30.5, 30. This, the most normal looking one, look at that. 24. Oh, well, that's the lowest possible it can get. So that right away means it's the least gerrymandered. A simple algorithm could take care of that. The problem then comes with the fact that it would just take anybody, regardless of the demographics, and put them together. So you could end up with a pie shape where there's some people from urban and some from suburban and some in rural, all in the same district. So I started thinking about that and how some states, Oregon comes to mind, has a problem where the urban districts are bullying the rural districts. So let's start up with what exactly a voting precinct is. All right. This black line here, this is a county line. All right. This black box represents a city zip code. The red indicates one fire department. This red indicates a different fire department. Blue is for water. Blue is for water. Green is for school districts. Okay, so we have right here a person that lives in the zip code, but they have southern water and they have southwestern schools. So their ballot is going to be different than the person who has northern fire, same zip code though, northern water in northern school district. So each one of these is a polling location where they each have, everybody in that location has the same ballot. So each one of those polling locations is going to have a separate population. So when you're looking at redistricting, you can't look at the individual. You actually have to look at the polling location as a collective. It has a discrete value of its population. So now I made this generic map of polling locations. All right, and for simplicity's sake, they all have the same area. And these numbers actually represent population density, because I feel like people that live in areas with similar population density have similar needs. Now, what party are they in? Yes, we tend to see more urban people voting with the Democrat Party and rural people with the Republican Party. I don't care. It doesn't matter. It shouldn't matter what part. Certain areas are going to have predominance of certain parties, and that party should win. The goal shouldn't always be to try to make it fair to the competitors. It should be fair to the people that live there. So anyway, I don't care about what their wants are, but they all have the similar needs. All right, suburban people have similar needs. Urban people have similar needs. Rural people, different but similar needs. So what we do is we started with the one with the highest population density. We start there with that polling location, and then you go to the next closest one in value. So in this case, it was the 8. So they have population density of 8. They have more in common with them than somebody with a population of 1. So now we have an 8 and a 10. All right, so we're surrounded just like Minesweeper on the old Windows computers. Okay. So 8 and 10. The next closest thing is going to be a 4, and another 4, a 4. Anyway, we hit our target total. Then you move to the next most dense place, and you start similar. Now, where you can run into problems, you have to institute certain rules. Is when you're creating these enclaves, they cannot create an enclave that has less than the target amount of people that you need per district. So in this example, this one here, we did the 4 and the 7. All right, the 3 comes. The next one would technically be this 3 and this 5, but that creates this enclave right here, which has no possibility of meeting the minimum threshold for a district population. So rule goes, you take the closest to your population density that is contiguous to you, that does not create an enclave that is below the minimum threshold. Now, the first algorithm, the shapes are going to look much nicer and more regular, aesthetically pleasing. This one has a district that's like this, comes down here, comes over in here. We got this thing, it's almost the same as that. All right. But that was not chosen by a politician. That was chosen by a computer algorithm based on the fact that those people have the most in common with each other to form a unified voice. So anyway, there's the answer. It's really simple. I don't know what it's going to take to have it instituted, but let me know what you think in the comments, and stay free.